Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on product of array except self. So the problem states that we are given an integer array nums, and for each index I, we need to return the product of all the elements in the array except that particular element. The constraints are we cannot use division operation, and the solution must run in O of n, and the output array does not count as extra space. So if you look at this example, if you are running it for index 0, which is 1, the answer should be 4 into 3 into 2, which is 24. At index 1, it should be the product of 4 into 3 into 1. So the answer is 12. For index 2, which is 3, it should be the product of 4, 2 and 1, which is 8. And if you are running for index 3, which is 4, it should be the product of 3 in 2 and 1, so it is 6. So for the brute force approach, the idea is for every index we will loop through the array and multiply all the elements except the current index. For that we need 2 loops, and we will skip the index when multiplying. We will store the product for each index. So let's start initializing with n, which is the input array's length, and let's also take one more array which is nothing but the resultant array of size n. So let's start iterating from I0 till the end, and the second loop also starts from I0 till the end. And let's take one more variable product initialized with 1, because we are multiplying this. So if you initialize it with 0, the answer will always be 0. So we have to initialize it with 1, because anything multiplied with 1 is that number. Now the main condition is it should not be of same index, so I should not be equals to j. Then only we will multiply or update the product into equals to the current element at j index. Now after coming out of this, let's update the resultant array at index I with the current product, and then it will go to the next iteration. At the end, let's return the result. Let's run the code. Yes, it is working. So the time complexity for this is O of n square, because it is using 2 for loops end to end, and the space complexity would be O of 1 if you exclude the space, because it is mentioned in the question that it is not considered. Just in case if this is not considered, the space complexity is linear. If the output resultant array is considered, then it would be O of n. So this solution works, but it is very slow for larger inputs. So let's think of an optimized approach. For this, instead of recalculating the products again and again, we will store the product of elements to the left, and we will store the product of elements to the right, and we will find the final result. So for that, let's initialize a variable n with the length of the given array, and also the resultant array of size n. Now we need left products. For that, for the left products, let's say the resultant of 0 would be initially 1. Now let's update it. Int I starts from 1 because 0 is already updated, just like the prefix sum. Till the end, I plus plus. And now let's update the values from second index, which is result of I is equals to result of the previous index multiplied by the current from the input array. Now we have the prefix product, I would say. And now in the step 2 we need write products. For that, let's initialize a variable write products with 1, and let's start from the end of the array. So for that, let's loop from n minus 1 till the beginning of the array, I minus minus, and let's update the resultant array with result of I into write products. Okay, now let's update this write products. Better to say it product instead of products. Let's update this into equals to the current element. Let's call it product. Okay, now at the end we will return the result. Let's run the code. It is accepted. Let's submit it. Alright, it is working. So let's take an example and dry run the code. For example, if you considered example 1, the input is nums of I, nums 1, 2, 3, 4, and the left products will be, let's say the left products as when you're calculating the left, the result would be, so initially result of 0 we made it 1, and how did we calculate the rest of the other elements? We are simply multiplying these numbers, so it would be 1 into 1 1, and 1 into 2 2, and 2 into this 3 is equals to 6. So 1 1 2 6 would be the left product. Now we need to update the right products. For that, we are updating the resultant array itself. So result would be, yeah, so now the result would be, we are starting from the last index, which is index 3. Since we have 4 elements, the last index would be index 3 as it starts from 0. So now we will be updating the last element, which is nothing but 6 into 1, which is 6, and then we multiply 2 into 4, which is 8, and then we multiply, now we are updating in reverse fashion. So the last element would be, result of 3 is result of 3 into the right product. So right product is 1 initially, so result of I is 3. So 6. So 6 into right product 1 initially, so the last element is fixed to 6. Now the element before that, now result of 2 is equals to result of 2 into right product, but here we have already updated the right product to, so it would be 2 into 4, which is 8, and then it would be 1 into 12, which is 12, and it will be 1 into 24. 1 into 24, which is 24. Now, so this is the final output, 24, 12, 8 and 6, which matches the output. So yeah, so the edge cases are, this works with 0 values, this handles negative numbers, and we did not use any division operator, and the output array is reused again here as left, and we have reused it in the right, so we have saved some space. So the time complexity for this is O of n, and the space complexity would be O of 1 if you exclude the output array result. So this problem is a perfect example of prefix sum and suffix computation. So this is nothing but prefix and this is nothing but suffix computation. And yeah, this is also commonly asked in interviews to test the space optimization, to test how you are traversing through array, and to test your logical thinking without using division operator. So yeah, that is it for today's problem, and I'll see you in the next one.